Alright boys, we are back once again to this project that I thought I was going to finish in a single video, but we are already in the fourth one and there is a bunch of stuff missing. So, I thought about it offline, and by the way, yes, we are in another late night session, so I don't have that much energy, but let's keep moving. So I thought about this, and I'm just going to remove the scratch pad and just have for the words that have arguments like this lit. I don't think there is any way of avoiding having codes for the compiled stuff and code that executes immediately, right? This one can be shared because it doesn't have arguments, but this one needs to be more or less duplicated. So in that case, I guess we can begin by having the function, the compile time function, I guess. And in this case, we don't really, let's remove that for now. So we can just tie this stuff up. And this one is going to be executed for the compile time, or the immediate actually. And here, so we receive this value by there. I know that we can copy the assembly because we still need to manipulate the register, so we can have that there. But this needs to change, this move a BSQ, right? So let's search for Intel move memory to register, right? Something like this. Intel move 64-bit value, actually, because yeah. Is there any like manual I can move Q? I suppose it's this one. Move Q. This one. So it needs SS. Oh, from XM. Okay, but I want. Oh, this one. This is what I want. Move Q. Which moves the quad word from. No. I want it the other way around. I want it to move from memory into. Oh, but it's basically this one. From memory to register. So we need that one. Okay, so let's use move Q, move quad word. I assume this one is the one that we need. And here, I'm also going to assume that this is actually going to work. So let's assume this is going to work if I replace this by an argument. So this was the output, this is the input, I believe. Yeah, this is the input. And here, this input is going to be in memory. And we can either pass the variable, I don't know if this is going to work, or we can pass a pointer to the variable. Let's try this first. And here, we can remove all of these because this is no longer needed. Let's remove all of these sheets. Yeah. And let's just execute that with a number like so. And like have a few of these just to have something on the stack to print. And let's try to run it, or actually compile it. Oh yeah. By the way, I'm already inside WSL, so I initialize VS Code from within WSL, so it should be easier. Main.c, then I need all and std c99, and then I need to execute main. Oh yeah, I forgot this. Lit begin is already defined. Yeah, because we don't actually need any of these, and we don't even need to return, right? We just need to execute this because the function is going to return by itself. So we don't need none of that. All right, so if I do 42, it didn't do anything. Why? So this one, it still pushes the stuff, the current value onto the stack, but it is not doing anything. Should I use this one? I mean, no. Okay, so GCC assembly, move var into register, something like this. This is not really what I need, to be honest. Um, mm, yeah, but this, I don't know if, let's ask the Clanker, because like Google is even more stupid than Clankers nowadays. It's just so weird. Maybe we can start a new one since it's a new video, or actually it would, yeah, whatever. Um, this code prints the stack fields with 0. Fix the lit function. Yeah, I'm just going to give a very clear instruction to the clanker. So it's basically updating the stack pointer and the top of the stack value. So it's telling me to first move, but I cannot do that because if I do this, yeah, but if I do this at the beginning, the top of stack is going to be lost. I need to push it first. Like, as usual, clankers are useless, but they still can be more useful than so what the fuck did he do here? Then load the new value into R13. That's what I did. And finally store RT13. But yeah, it's you first load the value R13, then store R13 at the current stack pointer location, and finally increment. Yes, but the top of stack is just in R13, while R12 points at the second value. Just fix the issue. Do not hallucinate new ones. I don't even know, like, god damn. Let's try this one. This is with 6 expression operands. Like this documentation is 100% useless. So this is what we saw in the last video. I just want like input operands. Is this what I want? They could have proper examples. I mean, generic operand modifiers. So much text. I swear. So here they move C3, that stuff, from to count. Okay, but that's more or less what I'm doing. Go to labels. Huh. I mean the usual, unless like the variable is not being loaded, right? Unless it's not being properly loaded. Let's see what the clinker said. So here, that's what I did. Then here, that's exactly what I have. Then here, that's exactly what I have. If I replace this M for R, are you going to do something? No. So it's exactly the code I had, and it does not work. Is there any is this like a stupid issue like I had previously in the previous video, because I was eating my heads for quite a while, not really understanding what was going on, but so here we are loading that. If I happen, well, here I'm using move Q. Okay, yeah, that's what I need. So this is correct. But here I'm using R instead of M. So let's use R as well. Fucking hell, it is not an issue with assembly. Find the bug. I should like start using GDB or something. It would probably be helpful. So we do that. Here it should be fine. So if I initialize, let's say R13 with something, let's try that. If I happen initialize the top of stack with some value, like I don't know, 42 for example. Where was it? Oh, yeah, it needs a comma. If I say like something like this, yeah. So this, it seems like it's not being called even, because yeah, it looks like it, doesn't it? That this function is not even being called. Hello, if I do this, like there is something strange within this specific block of assembly. Let me just wrap it around. So we got B, it executes stuff. So why is it never? That's what's strange, isn't it? So if I do, for example, the following, I come here and I hardcode this to be, I don't know, like 69, for example, and I temporarily remove this. Yeah, it's not doing its stuff. So why is this assembly code not executing? What is going on? Huh. At the base of the stack, sure. It doesn't matter. So, yeah, this should not matter. It looks like the assembly is never called. Well, in reality, I did, but I'm not printing the register, right? I'm not actually printing the register. Let's do the following. So here for the stack, well, we can print the entire stack. Yeah, let's just print the entire stack just to make sure that the clinker is actually incorrect. Yeah, the clinker is incorrect. for sure. So we can remove this, do not have that code. We can remove that. Yeah, so it looks like the assembly is not being executed. GCC inline assembly not being executed. Is it because it's volatile or something? It's the compiler that does register allocation. To make sure constraint is picked up. Huh. That still does not really... Okay, the assembly code init function is not being called because you are not actually using it anywhere in your code. The code settings. Fucking hell, like... sure, that code still does not do anything. Like, sure, yes, I'm aware of this. Thank you, Clanker. I am fully aware of it. So I should use, let's use R, because I know that this R works, so at least that. Or actually, okay, yeah, it was working on the previous video, so it needs to work now. You're not initializing R13 with the top of the stack value before calling lit. What has that to do with anything? What? So let's say I do the following. If, yeah, if like, if I do this, it's all zeros, right? Everything is zero. But if I initialize this stuff with 69, for example, it did push 169 to the top of the stack. Because if I don't call this stuff is not, so one of its call, the first call is pushing at least the current top of the stack into the other stuff. The issue is that when I call it again, for some reason, it is not doing what it's supposed to, right? I think so. So if I just grab this and I just literally just write it like this, and here I use num, right? If I do this, is there any issue like with the function calling? Maybe some weird stack frames or something? Okay, so yeah. So when I call this inside a function, so there is something very strange. I see. So if I change this to M and I comment all of these and then I uncomment that, what is even, why is that? Okay. So if I inline in the main function it works, but when I wrap it in a function and call that function, it doesn't. Why? That's a very, like, there is that must be something with the stack frames or something very strange with this code. But these are like call is saved, right? So these are call is saved. Oh, I fucking see it now. Because since R12 is call is saved, that means that this function is going to store the value of R12 into the stack, right? It's going to push it into the stack. R12 is going to be completely freed up, or it's like it may have contained trash or something that is completely unrelated. And then here at the bottom, R12 is going to be restored, right? So we need to use the other stuff, the call saved. Or do we? I think this is an issue with ABI. I think this is an issue with API. Let's test that idea. And where is, yeah, so this is the API. And this is system 5, this is Windows. So these registers are color saved. So we have 8, 9, 10, and 11. Sure, the shadow space is used to speed, but must be made available to all functions, even those with few. R10, R11. Caller, exactly. So the person who calls these registers. Yeah. So one. But I don't understand why this worked. Oh yeah, this worked before because I was copying just assembly into a piece of memory, and I was executing that piece of memory without having all of this fluff that C adds, like all of these ABI conventions. That's why it worked. That's why it worked. And in here, the caller saved. So this is callee. Where is the caller? Sure. So the caller. So this I don't care. I only care it says this for Microsoft caller colon caller caller. Yeah, so it's we only have R8 and R9. Let's, well, what kind of solution can we do? I actually need to think about this. This is actually a very interesting issue, right? If I replace this, if I happen to replace these mentions by R8, for example, and these ones by R9, is this going to work now? Oh, and I still need to replace this by R8. Yeah, and this by R9. Because it's going to be harder to interface with C if we don't get this issue resolved, right? We need to fix this issue to be able to have FFI with C in a proper way. No, it's not fixed. Did I already mention? I think it is an API issue. because here what they tell, because if I just execute the exact machine instructions, it works. It must be something with the fluff that the C compiler adds, right? It must be something like that, right? How can I feel? But well, one way is to just initialize the program and copy exactly what. But then, like, this is going to be fucked, because if we want to have FFI with C, then this is going to blow up. So we should find prolog which serves as restore system registers. However, it seems that R12 and R20 are not being saved or restored, which means that their values are being covered. Okay, but how do I? Oh, attribute naked. Well, there's one option. There is in fact one option. So I can try it. And if attributes are not permitted in function, let's try it either way. Here I need to add a return instruction, because then this is not going to have any fluff, right? Yeah, so this is not an option. Naked function in GCC, and we'll need to actually in the future think about how we can interface with C, because yeah. Yeah, but I already use volatile. What the fuck are you talking about? R12, R13, yeah, R8, R9, yeah. You can align assembly with the ASM keyword and specify any input operands. Bro, that's exactly what I'm doing. These guys are completely... Oh, so it's... I should use an attribute before, not after. I'm not very familiar with all of these GCC extensions, I'm gonna be honest. Okay, so this worked. Well, but it's still fucked up. It is still fucked. Well, because now it's... yeah. It's actually a very interesting thing. So I think I'm just going to bring back, just to simplify stuff. Let me bring back the other stuff. So it was a R12, right? R12 and R13. R13. And here, for the function that's going to execute immediately, I can do the same trick, right? I can do, well, I can even, okay, let's create a function that initializes our state. Right. So this is going to be responsible for initializing, and in that case, well, here, why did I feel the need to do this? Let's try that. Yeah, let's try this first. So one last try before I jump into another thing. Let's try this. let's call this n, I don't know, and let's do this register. Let's remove that, and let's try this. Maybe that was the issue, I don't know. Okay, that's it, but pushed one. Yeah, if I add more now. So that was, no, it's still fucked. No, it is still fucked. Okay, and here the code is exactly the same, right? So R13, R12, 8, R12, and the only thing that changes is the move queue. Yeah, so let's bring back the void init, right? And here we are just going to initialize stuff like this. So here we are going to initialize a stack. Then we need to initialize our thing, and this one does not need to be here because, well, I can leave it just to be safe. We need to initialize something, so I want probably, let me think. I'm thinking if I want to have the vocabulary in the same segment as my like intrinsic init words. Well, I can have it. I don't think it's going to have that much of an issue. So why did I don't know why I did this, to be honest. Let's go here. Yeah, I think I can just assign it for calls right now, like this. So this is basically initialization of the pointers and everything. And here we are initializing the executable memory segment. And here we will need to initialize this lit stuff. And this lit stuff is basically going to be like, is this a proper declaration? I think it is. It's basically going to be this. Can call it roll or something. Roll it, and I can literally just have it be a pointer, right? Something like this. And then here I can basically just mem copy into code. The source is going to be this one. One other thing that I could do is I have dupe size and also lit size, so it's easier to keep track of stuff, because then, well, actually these are not external, these are in fact generated in the init function, like so. So here this is just going to be, so we can initialize them right here. This is just going to be dupe begin, dupe end, right? Like that. Here we can cast it into a pointer, like so, and we do the subtraction like this. And then for lit is basically the same, we just replace the word by lit. Oh, that's not what I want. Right. Here I could use uint PTR. Well, it's actually better to use uint PTR because this is a subtraction of pointers, so it's okay. So here I'm gonna copy into codes from where, from this lit begin sharp pointer address like that, and this much lit size, right? And that's it. Oh, and I need to increment code by lit size. So this is the entire initialization. Oh, and I can, yeah, I can say, well, I can call it underscore lit or something. and I can say this, and I can assign. Okay, so this is the start of the lit in codes. And I can say points codes. Right. And then I can make code and I can attach other stuff into it. And then here, this function becomes trivial, because in this function, I just need to do the following. So this is also not needed anymore. I can literally just call init, and it's going to do all of the initialization for me. And here I can just patch it, right? Do the last bit of patching. Now that I think about it, well, I copied this. I still need to attach. Well, I don't. Do I need to attach the return? Wait a minute. Yeah, but I was calling it directly. So I need to attach the return, and the return is C3, right? Let's go to the, not this one. This is not that useful. Yeah, this one actually interesting. Do I have the rights? This is interrupts. Nope. Yeah, this one. What is the opcode? Yeah, it's C3. Near return to calling procedure, far return. Oh, but they are different. Interesting. I don't know what's the difference between them. Returning to a calling procedure within the current code segment. The segment currently points to by the CS register. A return to a procedure located in a different segment than the current code segment, sometimes referred to as an intersegment. Yeah, let's just use C3 for now and assume everything is going to be within the same segment. I don't know what's the size of the segment, but we can patch it later if it's actually required. So here we can say codes at this. So this is basically what we did in the previous video. There's nothing new. And 0x C3 like this. And here we just need to increase an extra byte. Right, so this we are doing that. And then for this, we can basically just do mem copy, and we basically need to copy into underscore lit plus lit size minus size of uint64, right? Then the source is basically going to be this one. We just cast it into a pointer, and this is basically the same. So this one, right? And then we can literally just call this mother flipper, right? And to do that, we can just use this kind of stuff. I can say call like so. Yeah, like that. Here the output, I don't care. Here it's basically going to be the, well, I can extract this into void pointer press. It's a bit prettier. This is going to be, I'm gonna say R, because I don't know the difference between them. And here for the cobbler, I guess this is going to change the memory, probably, right? Memory and this, because it doesn't change the other stuff, I presume, right? So we call this sheet, then we call it directly, then this eventually returns, it comes back here, it returns from the function, and it's basically that. Let's try it. Okay, operand size mismatch for call. Okay, let's see what what the clanker says, because I don't feel like, well, I could read the manual, but it's going to be slower, right? Not this one. I need to, okay, let me just close on some of these useless stuff. Yeah, this is also not needed. I need for the call. Well, while I research this, I can put the clanker to thinking. Alright, let's see if the clanker does it. Call procedure. So this needs, I'm passing, well, but it should work, right? It should work. What is it? A memory address as an operand. No, I want to use the memory address as the call value itself, not the value at the memory address, right? Tells assembler to use the value at, yeah, I want to use the pointer itself as the address. Call Q instruction 7. Okay, so maybe that's why it was complaining. Call Q, and I'm not going to add that star. Okay, did I save it? Okay, if I add that star in that case, well, yeah, this needs to be this indirect call without that. And with what if I use call? Okay, so it's complaining that it needs it. What? Like, I don't understand why it needs that, but okay, it didn't fucking, why didn't it work? God damn. So I basically, you are telling me that I'm unable to execute code outside of the main function. Is that what you're telling me? What the fuck? That's basically, yeah. I'm basically unable to execute code. So I'll be forced to do shit. You know, well, to be honest, this code is not going to be duplicated. Well, it could be actually duplicated, but I'm basically forced to do this shit inside a macro. Because, yeah, I cannot have naked functions. I cannot, like, execute it directly from within a piece of executable memory that does not have all of the fluff that the C compiler adds to the functions. I cannot do any of that. So I'm literally forced to inline every single piece of assembly and pretend it is a function, right? So if I do this and I try one last time, and I have some literal number x, okay. And here I can literally just copy this and bring back whatever we add previously. So this is not needed. This is not needed because it's going to be inline, right? If I do all of these, right. Here I just need to change to move Q, and this one needs to be replaced by R and then X, right? Basically. Yeah, something like this. So I'll be forced to use, this is like my last idea. Like I don't even know. This, at this point I don't know if it would be easier to just write this shit in directly in assembly. Because interfacing assembly with C, with force and all of that shit is it's starting to get quite hard, I must say. So if I do this a few times, is this going to work? Segmentation fault. Okay, so there is some well, let me just bring back whatever code I had before. Yeah, it is a move q r x. Why don't you like that? So if I do these codes, if I do all of these codes in here, are you still going to complain? That's the question. Let's just say num. So I'm using moveq, which is a correct one. Yeah. Then this, I'm not using that. Okay. Let me see. No, it's some issue. What code was I providing previously? So this was working. So what's the difference? So num. So it is initializing properly, I assume. So that's SP. Oh yeah, because this is assembly. So fucking hell. So this, since this is assembly, it needs to be literally in line inside the main function. So every single piece of assembly needs to be inside the freaking main function. That's so dumb. That's so freaking dumb. I literally cannot use any piece of code inside function. So I can only define shit like this way. I need to then copy it into a chunk of memory, but I need to always call it and execute it within the scope of the main function. Like, is there any way to tell GCC to not use these registers? Is there a way to tell GCC to not use and just keep them as they are? Whoa. Okay, because otherwise, I mean, let's try this code first. Okay, yeah, because this shit is working. But now if I call this macro, let's test if at least the macro works, right? And if I call this macro a few times, I say like 69, yeah, it's working. So we figured out something. Every piece of assembly code that I write needs to execute within the main scope. That's so freaking dumb. So I don't want to use fcall save, but I don't want to use to tell GCC not to generate a prolog or epilogue for a function. But yeah, I don't even know what the fuck this is. And restore. This will save. Yeah, but that's not what I want. Like, I want the compiler to not use or change r12/r13 in any function without needing a special compilation flag. I don't even know if this is possible. Like, I'm already stretching quite a bit. Like, the C compiler was never created to handle this kind of shit. So maybe I'm already stretching it quite a lot. Yeah, I mean, yeah, it's basically, yeah, it's already giving me like macros that I don't want to use. Okay, but that's a constraint we can work with, right? That's a constraint we can work with. Now we need to do the following. So we need to initialize SP to be stack -8, okay, because we are always going to like this is actually the second value, right? Because SP is going to actually point to the second value of the stack, so we need to fix that. Size of uint 64, right? Because SP points at the second value stack, while R13 holds the top value, right? So just to make sure that's properly documented. So then we do this, we initialize everything we need to initialize, and then we can have our stuff. So here we should no longer have this trailing 0, I presume. If I do 42, oh, it's not even work. Is it stack minus or stack plus? So this is a pointer. If I change this to that, it's either one of them. Oh yeah, because this does the, yeah, it's not minus, because this is not this is pointer arithmetic in C, so it already takes account the word size, right? It already takes into account the word size. If I do that, okay, we no longer have the trailing, and we have 1 2 3 4 5. We have 1 on the register and then 4 trailing 42s, so that's okay. Okay, so that was quite enriching. Let's do the following then. Let's start parsing some words, I guess, right? So we need to bring back that chain of things that we had in the old codes. Like in is I64. Do we have it goes here? No. We have it here. Is I swear I had some codes that checked. Oh, it's here. Oh, it's all digits. Okay. Yeah, we can have this function and this function. We just copy them. Those are quite useful actually. So this is more related to that, so we can keep them like here. Yeah, sure, we can have static inline, but this requires C type, right? So C type, and then here we say is all digits. If this word is all digits, then we do something else. If we do something else, and in this case we only have dupe and bushlet, right? So we can just handle them like that. So here I just need to do 2 I64 and pass the word, and this is going to give me the number, and then I need to actually put it inside a variable. That's very important, because my macro needs it, right, as a variable. I don't think I can provide, well, I can try, but I don't think it's going to work. So let's first try it like this, I64, and I can remove these codes, and here I can do strcmp words with loop, right? And here I test it if it is the same, and if it is, then I need assembly code once again, but I think I can, yeah, I'm gonna just do this. I can say call, and this is going to be the address, right, just to simplify stuff, and I don't need to repeat myself so much. Here we are literally just going to do a call to a specific point. So this is going to be this stuff, right? I believe so. Here we don't need any of that. Here we can have the address. Here we just going to change that, I believe. So this should be our call, like so. And so here in the dupe, I can instantly reuse this code because this doesn't have any arguments. So I can literally just say that. Yeah, and I can, my macro can even do the casting, I believe. So I can do that, and just cast it into a pointer. And this is a little bit easier to work with. So I can say loop begin, and this should work all right. Okay. And here I can say for or you can say while words, I can even, yeah, I can do a for loop. Why not? So I can literally just say this, and then words, and then word is equal to next. So that's one way of doing it. Yes. And then I can just put everything inside a for loop. And once again, we need to guarantee that we don't call any function. So all of this is macros, and this for loop cannot be placed anywhere else besides the main scope, right? Either the main scope or wherever we initialize our R12 register, I believe. So because issues that R12 is being discarded or something, I don't know. Let's try that. Inject all. So I once again forgot how to do this shit. Alright, so here I suppose I had some call. How did I do it before? I know that I had this working. Like, oh yeah, I did that. I called it here. But I want the assembly code that was calling. Maybe I never did it, and I'm like misunderstanding what or misremembering what I actually add. Here I think I already also in this chat already talked with it about its call space. Here he used call queue, but maybe no, this is correct, right? If I do this, okay, loop. Well, I can say like 5 and then loop, but I'm not actually consuming Control D. Oh, I am actually. So the dupe word is not working. Huh. So let's actually wait a minute. So if I do like 1 and then loop and then I terminate, I don't think dupe is working, because if I do 1 1 1 and terminate, we have 2 trailing and 1 on the register. Yeah. Here could I let me check if it's possible. Also print the value in R13 as the first element, because it's easier to debug exactly what the fuck is going on. So what the fuck is this doing? What, like this claim, just extract the value inside R13 and print it. I swear. So this is, yeah, we can do that. Oh, so this is what it is. Oh yeah, we need to use the output stuff. Exactly. Let's extract that. this is actually useful code. And we are using move Q, and we are moving from R13 into this. Okay, we can call it R13. It's fine. Here, and then here we can print it like that. Yeah, and I'm thinking about it. So R13, I'm thinking about it. We can actually even be smarter. We can have R12 as well, right? So we can have both. And here we can do this here with that and R12. So we are moving both values out of it, right? And then, so I print R13, and then I just need to print as many values as R12 minus minus, where is it? Is stack, I believe, minus stack. But I don't know. This is going to give me the size in bytes, right? This is going to give me the size in bytes. So this is not really a, let's say int 64. Fine. So int 64. This is going to give me the size in bytes. Can I do this? Actually, yeah. Let's assume this is a sharp pointer because it actually makes more sense because they are both pointers, right? So this is pointer arithmetic, and pointer arithmetic is already going to give me the number of words, I believe. Maybe. Let's try it. So stack. Oh, stack is a uint point. Okay, we can make it a uint ATR. Why not? So if I do that and I terminate, I get 42. Okay. So we are now printing the value at R13 and then the trailing stack that is pointed by R12. All right. So if I do 1, 2, 3, 4, 5, I should see. Oh fuck. So I push 1. Let me think about this. I push 1 and then I push 2, 3, 4, 5. Why did I print 5 first? Oh yeah, because I'm printing them in the incorrect order, right? I'm printing them in the correct, because my stack grows upwards, not downwards. Well, we could fix that and make it a proper stack. I guess we could do it, I guess. And that's very simple to do it. We can just do, instead of add q, we can do sub q here and sub q here. And then we just need to say here, instead of doing this shit, we just say stack minus stack size, or actually plus, because it's going to start at the end, and then I need to do the following. So I need to do, well, either way we still need to manipulate this for loop, because here I'm gonna start at R12, right? Yeah, I'm gonna start at R12 and then I'm gonna move all the way up. So I'm gonna say P, so this is going to be a pointer, and I'm gonna say this is R12, like this, and then while R12 is less than stack plus stack size, right? I'm gonna basically keep incrementing the pointer, and here, instead of doing that, I just dereference the pointer. I think that's more or less it. Yeah, it doesn't. Okay, let me do the following. So this is going to be a uint ATR R12. Well, either way I need to cast it, so it's fine. I need to cast it either way. And here is not R12 but rather P. Right. Let's try again. Okay, it didn't complain. So I do 1, 2, 3, 4, 5, 6. And then I terminate. I have 6, 0, 5, 4, 3, 2, 1. Yeah, because here. So my stack is growing downwards. So I need to increment it by 1, I guess. Where was it? It's here. Do I need to do this? Or is it the other way around? 4, 5, 6. And if I terminate 6, no, it's the other way around, I guess then. If I do that minus 1, 3. 3, 0, no, it's not that. I mean, I don't like my stack growing downwards. I prefer my stack going upwards and just, okay, let me simply, yeah. I don't like this. So add Q again. And then here I can do something even smarter, or at least I can try to do something smarter. I can do the following. Here I can say this is a uint ptrt r12 pointer, and this is the value, the cell. Here I do exactly that, and then here I can start my pointer at r12, right? I can start my pointer at r12. Then while my pointer is greater or equal than stack, right? Then I can decrement my pointer. And here I need to bring back that minus 1 stuff that I had, I think. 1, 2, 3. Terminate. 3. Fucking hell. Wait, is this a plus 1? I cannot even fucking remember what I did. If I do that, there's something. Fuck no. Wait a minute. If I do that, yeah, 1, 2, 3, 4, 5, 6. I don't know, a bunch of numbers. Yeah, so there's a trailing 0 and a trailing there. So if my stack grows upwards and I assume that this, yeah, it needs to be like subtract 1, I think. And here I cannot do that. I can do that or something like this. Okay, so no, this was correct. This one's correct, I think. Oh wait, so yeah, we cannot start at R12. We need to start at R12 minus 1. That's the first fix. That's the first fix. Because R12 is going to point at, or is it? Yeah, I think it's going to, because R12 is going to point at the free element on the stack. Because first, yeah, first we move. So this means that this pointer specifically is free. Then we add it. So increment it to another free cell. And then, yeah, exactly. So we need to start at this minus 1. And this go all the way to the bottom. I add a bunch of numbers in order so it's easier to debug. If I do that and I terminate, I have 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so this is working. Cool. So this is a code that prints the current stack. We can put it inside a macro, so it's like more tidy. And again, we need to unfortunately have this in all of this inside the macro because we need to execute it inside the same scope because of the reason you already called. We already know, right? So you can say print stack, right? And here you just copy paste, so nothing too special. I can do the do while trick, so I can have like a semicolon here at the end. And here we just need to add a bunch of stuff. like those. And then every time I execute like a word, I want to, well, it is, yeah, I don't, let me think. So I can, yeah, so I can say size t previous line physical line, right? And then if previous line is not equal to line, we need to update previous line, line, and we can print a stack. That's one way of doing it. So this is basically for debugging purposes. So why didn't you enjoy expected while? Oh yeah, I forgot the while here. While false. Okay. So let's try. So if I do 1 1, okay, it prints. Okay, I could print like a space so I can like differentiate. Otherwise, it's very hard to know exactly what's going on. We can do that, like 2 spaces here. It should be enough. Let's try again. So if I push 1 2 3, why do I get only 1 2 and 3? Oh yeah, because this is going to execute. Yeah, so I need to do the following. I first need to fetch the words and only then assign the line. Yes. Or actually, because I want to do this when a line change, but it's I can just add, yeah, I can just add like a variable. I can just add a variable because it's going to be easier. Here, so I can have like, this is first. I can order another boolean like line changed with something. It's going to be false. Well, but this still doesn't really capture what I want to do, unfortunately. Yeah, it doesn't. It doesn't actually. Um. Mm, mm, mm. Well, actually, so what this when this is called, I do that, and when line and this actually should work. What the code I had before. So why isn't it working? Because when the previous line does the stuff, and yeah, it should work. Let me just revert that. Yeah, it should be more or less like this actually. Yeah. So if I do 1 2 3 4, okay, but if I do that 2 4 3 2 1, it didn't print the last one. Yeah, it's not printing the last one. Yeah, so let me try to bring back the other stuff that I was maybe trying to do. So bool line changed, I'm going to set it to false, and every time this function enters, it's going to set it to false. But then every time I do this and it succeeds, line changed is equal to true. Right, so changed. It still may be a little bit fucked, but I don't know if I like this next approach actually. gonna be honest with you. If I do that, 1, 2, 3, 4. Yeah. But what if I do this, but before I even do anything? 1, 2, 3, 4. Yeah, it has an empty. But then if I push 5, 4, 3, 2, 1, like it makes absolutely no sense. Yeah. So I don't really like this next approach, to be honest, because it doesn't allow me to detect when easily. It doesn't easily allow me to detect when something changed. Well, I can think about that in the next video. Let's just simplify everything for now. I just want to debug dupe, right? I'm just entering in some weird tangent and it doesn't really add anything to what I want to do. So let's just print a stack at the end of the execution. So if I do 1, 2, 3 and terminate, we get, so we pushed 1, we pushed 2, we pushed 3. So the stack is 3, 2, 1, push 3. So the stack is reading from left to right, right? Yeah, I guess so. Well, we could, what does it make more sense? So G fourth online, or actually fourth print entire stack. What does force actually do? Dot S, the most obvious feature force. Dot S. Okay. Can I run G4th online? G4th online. Is that a thing? Okay. So this executes. Okay. This is a comment in force, by the way. So if I do 1, 2, 3, and then dot S, this is going to do. Okay, so this is going to read from right to left. So I should also print my stack from right to left. So I just need to swap them around. And I just need to say, so this is equal to stack. Then I need to say, while P is less or equal than this, or in this case is less than that, right? So it's actually that, and then plus plus. But I actually need to move all of these codes. Actually, this one, I don't need to move everything. I just need to move that one to here. And then here I can have the new line, and this one can have the other stuff. What am I doing? Okay. Can have like the two spaces, right? It can in fact have the two spaces. And these should probably print a stack similar to what fourth has. So if I push a bunch of values onto the stack, so I push 1 to 3 for numbers from 1 to 9, and I do this, I get one, which is basically what fourth has. So I can test it even 4, 5, 6, and then 7, 8, 9, and then I print a stack. If I do this, yeah, it's the same. So this is basically what force does. So we are doing the same, just to simplify stuff. Okay, but now we need to debug dupe. So you already know that the literal instruction is working. But if I do like 1, and then I do dupe, and then I terminate, I get 0, 1 for some reason. So let's look into this. So this one, yeah, is swapped basically. I first need to write it. I don't know at what point it will actually make more sense to first, well, to make R12 points, because when I want to pop, well, if R12 points at the second element instead of the first free cell, I think it would make our lives easier, to be honest. But let's double check that that was the issue. So if I do one loop and terminate, we get 1 1. So that was the issue. But because think with me, like when I do the add operation, I'll need to add. Well, it may not even make a difference, to be honest. But it's easier because I will not need to like move the pointer around. So if I actually do this, wait, if I actually do this, so I assume that R12 points at the value at the second value of the stack, right? It does not point at the next cell, free cell, right? So I need to increment it and then move it. Then here, assuming that I first need to free up one cell on the stack, then move the top to the second, and then move the value to the, yeah, that's correct. And here I need to do the same thing. So I need to do this like so. So I first free up the cell, then that, and then where is it? Here, I don't need to subtract 1, I think. Or do I? Maybe I do. I do still need to. Let's try it. 4. So if I do this, yeah, I have 0 0 1 2 1 2 5. What the fuck is going on? So something broke. I push 1 and I push 2. Yeah, something is fucked with literal. So let me. So I'm gonna free up. I'm gonna free up these. Then I move this into there. Oh yeah, but it makes sense actually, because now I need to actually subtract twice, I think. Or 1 2 4, but there is one value that's not being put. What the fuck is going on? Excuse me. So if I don't subtract anything, so if I do -0, in the 1 2 3, I have 0 0 1 3. Something is not adding up, right? If I subtract 1 here and I do 1 2 3, that's 0 1 3. So something is fucked. So let me think. Firstly, why does it even? So if I just print this, if I just do that, okay, a single literal works because it just pushes it into the register, right? Then if I do 2 literals, the register gets fucked, basically. The register gets fucked, but why? So when I do this is the source, this is destination, because this is AT&T syntax. Then, oh, but it should be fine. I don't get it. Why? What the fuck? So, let me try like 1 2 3 4, just to see what values actually go missing. Oh, we have everything. 1 2 3 4 5 6 7 8. Oh no, 8 is missing. What the fuck? Why? Let's see if the clanker can debug this. Finds why there 8 is missing in the output. I just moved the add queues before the moves to assuming that R12 points at the second value of the stack instead of the next free cell. Well, but But if, yeah, but I'm moving it, so adds Q, it moves it to the next 3. It then copies, and then, yeah, it should work actually. Let's see if the clanker can do anything about it. You should initialize it to a point at the stack. But yeah, but if I do that, then it actually gets fucked. Yeah, that's not really. Do not add before storing the value. So that's also one possibility because, well, is it a possibility? So if we first do this, but that's the point that we're trying to avoid, right? That's what we're trying to avoid. So this generates, like, I'm just trying to get some examples. And the curious thing about it is that, like, it's always the second, oh, it's always the second most. Oh, I see. I see. Since it is always the second, it's like our print is actually fucked. So we print there, 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 there. So this should be like that. No? Or should it? Let's try. Do that. Get 1, 2, 3. Right, but we still have 2 trailing zeros. Why? So that's what I want to understand. Why we have 2 trailing zeros. So if I push 1, so R12, let's try to visualize this. R12 is pointing at stack, right? I push 1 literal. Right, let me just move this comment upwards to be simpler. I push 1, 0, and this basically does that plus 8, right? Then it moves whatever was in R12 in R13 to R12, which is basically nothing because R13 was empty. So basically we will get the first 0, and then R13 R13 gets the value. So let's assume I pushed 1, right? Okay. Then it enters again. It enters again. It adds another 8 to R12, so it's basically the second cell, right? Cool. Then it moves whatever was in R13 to R12, so it moves 1 to the second cell. Okay, let's visualize. Okay, I should actually, okay, let's visualize it like this. Because this is the first one. This is, so it's stack plus 1. Oh, I see. This is stack plus 1. This is stack plus 2. And that's one of the trailing zeros. The other trailing zero is at stack, right? So we should subtract 1 from stack is still, because any operation we do, we either do this, right? We either do this, or if we want to have a safeguard, we just begin at stack plus 1. We start printing at stack plus 1 because this zero is always going to be here, right? Unless we want to use if statements, but I don't want to use if statements. So yeah, because then that moves there, R13 gets loaded with 2, and then we finalize the stuff. And this is a stack plus 1, right? This is stack plus 1. But yet, here before we have stack plus, we have stack. So if we do stack plus 1, actually we need to stack plus 2. Huh. Yeah, we need to do stack plus 2. Let's do it. So these should print correctly. I don't know if there is a better way to do this kind of stuff. I don't know, like probably Clanker is not going to give me a better code, but I understood the way we have the lit operation working makes it move, makes it skip, makes it always skip the first cell, because R13 is empty at the beginning. This, so we need to print from stack plus 2. Is there any other way to do this better? It's very interesting stuff, right? It's very interesting, but I don't see any other way, because we either way, moving this ads before or after the move Q, we still have the same problem, okay? And this problem arises from the usage of R13 as the top of the stack and R12 as the pointer to the second value of the stack. No, it's actually correct. The code is correct. It's completely outside the stack bounds. But what are you talking? Fucking this is. But assuming I want R13 to contain the top of the stack value and R12 to point at the second stack value, is there any other way to have a cleaner assembly that does not waste two values at the two first values? Waste the two first cells of the stack. Well, one way we could do, like, we could literally just push like argc and argv to the first two values of the stack, and we can just use them as we need them, right? But I don't know. Well, this is the idea I had, right? This is the idea I had. I mean, is one possibility. It is one possibility. Or but this still wastes them, right? This still wastes memory. You can then modify your lit macro to simply store the value at the current R12 and increment. So this moves there, and what am I doing? Yeah, that's not what I care about. Okay, but what does this do? So it is initializing it. So literal first moves, but this is not correct actually. This is not correct. This is very much incorrect, because this is going to clone the top of the stack into R12 to the value pointed by R12, and I don't want it. So there is one last thing I can think about that does not waste that much memory, and that's actually pretty useful. So here, instead of doing that with like hammering down code, we can simply do the following. We can say stack at 0, and we can just utilize this like more or less behavior of the assembly code, because I cannot figure out any better way of doing this. And you can just utilize these two free slots to push argc and argv, and that may actually be quite useful to the user. So that's one way of handling it. So you can just do that, and argv, and that's it. So we now yeah, this is should be that. That's correct. If I do this, uint pointer makes, okay, so I can just cast it to, yeah, sure. Well, this should not really, or should it? Well, it could be, yeah, it could be uint ptr, because this pointer is, yeah, it's actually there. If I do this, and if I literally just cancel it, so I'm going to have one. Well, but this is correct. I don't think it is 1 0. If I do like 3 4 5, so argv, is argv actually 0? If I provide like more arguments like abc, what am I going to get? 2 0. But why is argv 0? That's very strange. That's actually very strange. Firstly, this shouldn't be a uint pointer. This should be an int64, because that's a cell, right? And our cells are int64. Then let me printf, just so I can figure out what the fuck is going on, argv, and try to understand. Okay, yeah, argv has stuff in it, right? So what are you complaining? Okay, so this should be a int64, fine, and then this could be, yeah, this could be an int64, it's also fine. Then R12 can also be a int64, so pointer of course. Okay, so this does in fact have a value there, and if I turn, why is it 0? That's what I'm not understanding. Oh yeah, it's 0. It's fucking hell. Of course it's 0, because what's happening? Fuck. So what's happening? Yeah, this idea is also not going to work because of the following. Let me show you. Let me just align this because my OCD is triggering me. So somewhere we will need to waste 2 cells of stack here, unfortunately. Or I could actually, yeah, there is one way actually to, wait, there is one way to do it. Wait a minute. Okay, this is literally like peak OCD, guys. Peak OCD. Wait, okay. There's actually one way of doing this, and actually have it properly working. We could set argc, then, because argv is overwritten, right? Then we could, wait, let me think. So this one we have 1, then whatever we have here is gets overwritten, and then we start pushing stuff into here, right? So I just need to, if I push this file, I need to push there. Not really. Yeah, so if I do that and I push somewhere, we will need to have it an offset. Fuck, I was trying to avoid it, but I think it's inevitable. So what if I do this afterwards, of course, and I just do that. I just want to see what this exactly does, but I think yeah, it only pushes, so the middle cell is always fucked. The middle cell is always fucked. So we can have the offset here, and we can instantly push 2 items into there. So we guarantee that no matter what command the user does, this is always the R12 register is always going to have the correct pointer. So with this we have the correct behavior, right? We have the correct behavior. Yeah, that's the solution. So okay, we are using offset. We know that this is out of bounds. Fine, we know this is out of bounds, but this is perfectly fine because we also know that this combination of instructions of assembly code is going to put the elements in the exact correct place, right? So I don't think this is actually problematic. Yes, this is out of bounds, but the next two leaks instructions will move R12 to the third cell and initialize the first and second with argc and argv. Okay, so that's one way of doing it. Just recommend this. This will not access out of bounds memory. It is just the way we laid out the registers. R13 gets the top of the stack value and R12 points at the second stack value, right? So this, I think this is pretty self-explanatory, and this fixes like the issue, like, because I didn't want to have this offset here, because if I added this offset here and the user did like a dupe, we would be accessing out of or not really, but if the user did a drop, for example, yeah, if we did a drop, then we would move the stack into like a really shady place. So this one, I think it's fine. So if we push like a bunch of values like that, we will get argc, argv, and then a bunch of stuff. Okay, there's one, this may change in the future. I need to think about it, but I think it's a reasonable solution, and it gives the user access to the command line arguments that were provided. So that's, we were able to turn like a really shady code into actual reasonable feature. It's not that bad. It's not that bad. So to drop, like, we can add drop, like, why not? We can add drop, and now to add instructions is very easy, right? So because this is the only instruction that is going to take an argument, so this one is was the hardest one, and everything else is pretty standard. Pretty standard. We can just say, oh sorry, this is going to be drop, right? And to drop a value, we just need to copy whatever is inside R12 into R13, because we want to discard R13. So we can do this, and then we can subtract subq 8 bits from, or 8 bytes actually, 8 bytes from R12, and that's it. That's the drop implementation, the entire drop implementation. So let's add it like here, like so. Well, I could prettify this more or less. I don't know, something like this. I don't know if it is better or worse, but I'm gonna keep everything in the same line for now. And then I could have drop size. This is will only be useful when we start implementing column definitions, but we can already have those, that code ready. And then we do this, drop, and that's it. And then here we just need to support drop, and this is going to call drop begin, and that's it. So now with this particular like structure of code, is super easy to add and git compile forth commands immediately, right? And actually run machine code to execute those forth commands. So that's pretty good. That's actually pretty good. Like the only like really hard one was this one, but everything else is now pretty easy. So if we push 1, 2, well, first let me drop both values that we had on the stack. If I push now 1, 2, and 3, I should just have a stack with 1, 2, and 3. Exactly. So if I drop argv and I print a stack, well, it dropped the other one. What? Why did you? Huh? So it's dropping it in the incorrect way. Oh wait, I think I did a mistake here because I forgot to actually, yeah, I forgot to, no, this is, yeah, CC is drop. Yeah, I forgot to change this from place. Again, this is AT&T syntax. I need to remember this shit. So this is the source, this is the destination. Okay, so if I now do drop and then this, yeah, we keep argc. So if I do drop, drop, to drop both values that I don't care about, I add 1, 2, 3, 4, 5, 6. I drop, I should have 1, 2, 3, 4, 5, and if I drop again, I should have 1, 2, 3, 4. So yeah, it's working. Okay, so it's working. I just forgot to swap these two arguments, operands actually. And yeah, so as you can see, like to add a primitive instruction now, we literally just need to add a block of assembly, some boilerplate template stuff, and add it to this loop, and that's it. We just call it with our macro. This macro has some inline assembly to call an address without all of that fluff that C adds to functions, because with that fluff our code does not work, so we need to execute everything inside the same scope. I may try to find a solution for that. And yeah, like now we can add like infinite amount of primitive instructions. The only last one that is actually going to be hard as well is the colon definition, but the colon definition can be defined pretty much entirely in C, because I don't think we will need that much assembly, or we don't need assembly at all, because the colon definition is just going to copy assembly. So it's just going to mem copy between these bounds into code, and then store the pointer, and that's it, right? So I think we are pretty well. All right, so 1 hour 47, another very long session, but we were able to actually have some reasonable stuff in here. Like let's implement swap, like one last thing. Okay, why not? We have dupe, drop, let's do swap. So just so I can show you once again how easy it is to do this. So for swap we will need a temporary register, but we can use like R14 for example. This is temp reg. So this is drop. We can do swap begin and swap ends, right? And then we just need to move. Yeah, this is swap. Whatever value is inside this into, for example, R14. Then we need to move whatever value was in R13 into R12, right? And then we need to move whatever value is inside R14 into R12, like this, right? And that's basically swap. So super easy to add primitives, super easy. And then I just need to add, like, this workload is still not needed, as I said before, but it will be useful in the next video. Swap. Okay, swap and swap. And here I also need to add swap size here, like so. Cool. That's actually pretty cool. And yeah, of course, I need to do the mapping here, and then swap begin, and this is going to execute swap. So if I do swap, wait, like a normal problem, if I like terminate it, is going to have like argc and argv. But if I do swap and then terminate, we are going to have argv and then argc. So swap is also working. All right, now, yeah, everything else is pretty trivial. So we are going to work with in the decoupled definition next video. So thank you for watching, and I'll see you in the next one.